Hey, welcome back to Made Up of Wires. Is Made Up of Wires even a show anymore? Yeah, it is. Welcome back. We're decompiling Castlevania Symphony of the Night. Let's refresh Zynomo's page and see what the progress is. I've been gone. I haven't been working on this lately, but we'll pick it back up and keep going. We're decompiling. Eldritch just did something awesome, and I have not yet internalized the full scope of what he's done, but he was working on a recompilation project. And what is recompilation versus decompilation? They're mostly the same in a way, but a little bit different. The goals are targeting different platforms. Let me back that up. The goals are different. The goal of recompilation is targeting a different platform. The goal of decompilation, one of the outputs could be targeting a different platform, but it could just be studying the code in a way that it may have been written. And so how do these things differ? What is going on with them? Sorry, checking my screen over here. It looks like I was lagging, but I don't see any stats that show that, so we'll keep going. So when what we're doing here is decompilation. We're taking the game as it was, figuring out where each of the functions in the code exist, where the data exists, etc. And we're pulling those out into assembly, and then taking that assembly and trying to write C code that will compile to exactly the same thing. I haven't spent a lot of time with recompilation, but recompilation is an automated, non-transformative process that takes that code as it was on the disk and turns it into basically a high-level virtual machine for the target platform. So we're going to look at some assembly in a little bit. I'll load up one of these pages. And I haven't looked at Eldritch's repo. I'm assuming he has a repository for this. I just saw a little bit, but you can see that when we're decompiling things, we get C code out of it. Recompilation actually gives you C code as well, but the structure of that C code is very different. And let me see if I can get some assembly here. This is from a different function, but we'll pull it. Anyway, the C code that you're going to get, actually, I can't select this easily. Let's see if I can grab this particular. So let's take something like this. We'll just manually turn it into recompiled source, which may sound scary, and it's not that scary, but this is effectively what happens. Oh, that's not what I wanted. So imagine that you have an SDK, which consists of MIPS functions, a pool of memory. What else would you get? You need some globals probably for registers and some other things. And in the end, you need some way to get those hardware or virtual machine addresses to interact with hardware in some way. And so from what I've seen with the recompilation libraries, they'll include some compatibility layer for integrating GTE and the GPU and all that, the SPU with hardware. And so what's left then is taking the functions as they were And it's a combination of having a pool of memory as well as a translation layer for the functions. So instead of having a function with C, what we would, well, it is C, we would have a function that I'm pretty sure all of these are going to be void, and they're all going to take no arguments. And what I don't know is how exactly some of the branch delay slot mechanism works, but we'll take each of the instructions and we'll turn that into a real function. And $sign actually is a valid character to have in a name in C, so we can even leave the $signs there. And most of this can just turn into the same thing. Let's keep the label. But these just turn into functions, and so we have the addu function, the addiu function, and the registers are probably globals. They may be references to an array or some CPU state. They may be something else as well. They don't have to be globals. But we're going to basically rewrite our C code so that it looks like this. And this is a mechanical translation. So we don't need a human to be here to do these things. Like I said, I've not looked at this closely, just kind of briefly understand an overview of how this works. But you can imagine a C function that looks like this. Now, the offsets for these are going to be a little different. But let's imagine that all of this is translated in this particular way. So when you look at this, so then this is C code, so it can be recompiled to whatever target system you want, and it's portable. But it's operating on a virtual machine, and you're not getting necessarily to take advantage of being a native hardware. So what you're compiling does compile to native code, but this is not how anybody would write C code. But what's interesting is that this does allow you then to, kind of like we're doing with the assembly to C, take a ship of Theseus type approach and take something like this and replace it with a function that can be used. And it's a bottom up. You can do the pure functions pretty easily and replace them because they just take arguments, operate on those arguments, and return a value. Don't manipulate any external state. In a recompilation, technically, every function is impure because it has to manipulate the CPU registers and stuff like that, but we can replace them with pure versions. This is not quite a pure version. It operates, it's const, but it's not pure. Const meaning it is not going to change anything in any of the arguments, but it also is not going to, it also is going to read things outside of just the arguments that are on the stack. So how does this differ from emulation? Something like this. Not much, honestly. Are you compiled for a native system and do you need a separate emulator? No, but you need a runtime that's effectively the same as an emulator. You're building a virtual machine. So it's, in some ways, it's similar to how, not quite how a JVM works. JVM's a jitting interpreter. If you built a jitting emulator, that's a little more similar to how Java would work. This is a little bit like AOT, ahead of time compilation, where instead of having a big table where you're jumping to instruction implementation, you are calling those functions directly. So it's a little faster than emulation, but definitely not as fast or efficient as a natively compiled binary would be. It is interesting, but at the same time, it's a different and possibly more efficient way to play games that emulators can already play. And so it gives you a foundation where you can start replacing some of those functions. But at the same time, it is a completely mechanical transformation, or primarily mechanical transformation, which means it's somewhat difficult to distribute legally. So we're not gonna, that's where I'll leave that today. If you want to know more about that, feel free to chat, and we're gonna keep going. I'm not sure if chat is up or not. Usually I get a Stream Elements message in chat, and I'm not seeing that, so we will see what's going on later. So we were working on, and I know that I've probably led my entire viewer base by being gone for 2 weeks, and the internet has moved on. But we were working on Aurochs. I actually don't remember where we were. I think, if I recall correctly, we had finished off the function. I don't know if I had gotten it integrated into PSP as well, but we can keep going from there. Let's see if I will find. This looks reasonable. Can we do that Aurochs after image? Probably. Oh no, we didn't. Let's see if let's start with that. Yep, we have that one done. Why didn't I integrate that back? I don't know. Oh, it's possible that I have a stash. E-secrets, I think. Those are all dupes. Let's just choose something a little small to help me get back into the swing of things. Been gone so long. I'm actually going to take a few more days off. Life is busy. So, only 2 days this week, and then I should be back at a regular schedule sometime next week. Alright, so we have our C73 function, a bunch of things that the decompiler couldn't figure out, primarily because it can't figure out what the type is. I'm going to make the assumption that this is a entity, and it might be a primitive, but let's try entity first. Might be something else altogether. We'll see how M2C handles it. The unknown 29 is what's screwing it up, and there are some additional arguments that are not mapping correctly. They could be args to the function. We can see if we have anything yet that's calling this. Let's try primitive and see if that works a little better. And we also have that Borax structure, which may be what we're looking at as well. And it could be something completely different as well. So the X here matches, and the Y matches. So we could be looking at a primitive that may be true. The missing piece of this is, where do these subroutine arguments come from? It's possible that they're unassigned variables or something else. Let's look at this 2000 and the 7000. Those are interesting. We can find the PSP version of this and see if it gives us any more information. So here we're adding let's do a list, and we're going to use xargs to grep, and we're also going to look for the 7000. And the only function that has both of those is this 07C0 function. They're just moved to different places. It looks like it might be part of secrets, or maybe not. We'll see. Yeah, there's actually a good chance that this is just part of secrets. And if it is, I might have that done already, and just clean. Yeah, if it's part of secrets, it's done already. It's probably just named something else now. So we'll have to find something else. Something else to do. Let's look here. It's not showing up in a map file. Let's look for the 7000. Here it is. And it was a primitive. Alright, so we have that one done. I'm going to delete this. Let's find something else then. Do a little more due diligence this time. Okay, that one still exists. But I've done it already. All right, this one looks good. So I have some globals. See what else is going on. Looks like Sir Pounce is online. And some Symphony of the Night as well. Okay, so we have a void function, which is not the worst. However, we're referencing bar A0 and A1. Probably not that big of a deal if we have, if we're sure that this is void. We need to figure out what these two types are, and so we can do that by looking at what the stride is. And it appears that these are 16-bit values because our offset is 2 here. So I'm going to assume that it's signed. We won't know for sure. Can we get into it a little further? So we're going to make this a signed 16 array. EE0 is var A0. Oh, that was the one that I was looking at, var A1. Same thing there. So I'm going to assume 2 signed 16 arrays. It may end up being something else. Here, this looks like a signed 32 array. I'm going to take all these, put them in the context, and then we'll run M2C again and see what that gives us. Anything a little nicer. It's possible that these are structs, but M2C doesn't know. So we're going to treat them as arrays for now, and then we'll come back if they are structs. And it would be something like they're pos 16s or something like that. So we have a for loop that we need to fix. My guess is that this is actually 1 less than this, that the address is E4, and that we have A2 and A3. Probably just indexing off that. Just a single variable off of A4, or E4, sorry. So first I'm going to rewrite the for loop. Var T0 is our I. I'm going to make a new variable I here. And I is going to be less than x42, which is 66. Get rid of that T0 then. And I think var A0 and var A1 are going to be fine. I don't think var A2 and A3 are going to be, though. I think these are going to be a single variable, and I think this is going to be, like I said, starting at E4, and that's going to screw some things up, but let's do that. So we're going to just have var A3, and var A3 is going to be index 1, var A2. Yes. No? What was this originally? Yeah, var A3 is index 0. That makes more sense. And var A2 is going to be A3 index 1. And we should be able to do a var A1 plus equals 2, var A2 plus equals 2, and var wrong ones, A3 plus equals 2. Var A0 and A1. And that lets us get rid of these. These could also be in line. It may be that we're doing a plus here. I don't know for sure. So this is getting us a little closer. The shift by 9 is going to be times 512. I don't know if that's true or not. Or if it actually is a shift by 9, that's a little strange. There's no good reason to use temp v1 and temp v0. It confuses things a little bit. So we're going to remove those. Just do that inline. We already have the increment inline as well. And that lets us get rid of most of the variables now. And this is actually looking pretty reasonable. The only other thing that may be happening here is maybe var a3 isn't indexed. Maybe it's incremented. So we're going to try that. And we'll go from there. So we got rid of most every variable. It is possible that it is indexed, though. And that happens somewhat frequently. We may need the PSP. So let's try this just for kicks. Let's take our var here. We're going to say I times 2 plus, well, this one will be plus 0. And here we're going to do I times 2 plus 1. And see if that gets us any closer. I haven't saved yet, so I don't know for sure if that has gotten us any closer. We have a bunch of temp variables being set, which may make this seem like we're setting vars to the 40, 10, 70, and 27. But those are very discrete values as well. So let's do that. We'll make vars for all those T1, T2, E3. And then we can replace these down below. Interesting. That's getting us a little closer. Odd. I guess odd the way that it's structured, but that's fine. So the one thing I may try to do is let's try dereferencing this instead of using it directly. And then outside of the expression, we'll increment this. We'll do the same thing down here. And that is actually just deleted a paren. I don't think that's the worst construction. I don't know for sure that that's how this is done, but we'll give it a shot. And then we need to get rid of the increment up here. It's possible that the var a3 is done the same way. We actually don't have a var a3 variable anymore, the way that this is done. This game is pretty close. So it is possible that, let's put var a3 back. let's do this. Let's reference var A3. So that isn't working out as well. So let's go back to what we had. Really, the only thing... So we have some register issues and then a move that isn't working. Tried moving this back to a shift. It doesn't change anything, though. So I think that... I think this is pretty close. Let's find the PSP version. So we have some magic numbers, 70, 27. Those are pretty good numbers to look for. They are negative. That's actually probably good to add in there. Negative is hard. We could put a character class in there. Alright, so this looks like the right one. And we'll start with what we have. So, a little different. We could do one of two things here. Both of them, I think, are reasonable to do. We could... Oh, look at... So we have some math here that's interesting. I think we're seeing... So we're doing a shift left arithmetic by 10. But then we're doing a shift right by 7. So let's see what M2C came up with for that. This looks like maybe a mod 16. Or mod 255 maybe. I don't know. We'll see. Mod. Okay. So what if we change that to mod 255? Nope, not that. Mod 512. So the shift left by 10. And then a divide by 80 is going to be at 128. Shift left by 16. And then divide by 128. Interesting. And what it looks like is we're adding, maybe we have a so we're missing the shift left logical 3, which is a times 8. Let's look at the decomp again. Got it. Yeah. Yes. So that should be this. But we're doing it twice. And so we need to look at where this is. S4 is going to be RI. No, S0 is the I. These are all variables, that's correct. Let's change these to their PSP equivalents. I think there's one more variable that we're missing. And we should get rid of this var 3. Screwed that up. Oh, that's a thing. All right, so we have our variables. We're missing 2 variables. And what it looks like is that this var A3 is still being used. It's being used way down here. And I'm not sure quite how yet. Oh, I see. Nice. I think. So we're grabbing this variable down here. What did I do? Okay, let's get back up to where this is. So we're not doing this up here yet. We have a temporary variable, and those are the two that we need. So let's do that. Let's just call one x. I'm assuming that it's x because we have a pair, and we're going to do this particular math first. And that looks mostly right. I think it looks like these may be getting written back first, so we're going to do this in a couple steps. Something like this. I'm just checking the registers, making sure that they all line up correctly. So that looks likely. And so then the next step is doing the plus equals here. Oh, the next step is doing x plus equals. Different than I expected. And this isn't quite right. So we're getting two shifts here when we really want one. So that means that it is known. So this is a pos array. That's how I read that, which will embed the size in there for us. Pos 32. It should just be pos. Dot x. High. No, dot val. All right. So now we have the shift by 3 instead of a shift by 2, and then a shift by 1, which is exactly what we want. And then we need to write this x value back. And that will give us the last part of... and then, are we doing this increment? We are. We're doing that increment. Very odd way to write this, but now we need to do the whole thing over again, but this time with y. And that's the nice thing about the PSP version, is that we can tell all these gory details from its assembly that we would not otherwise be able to determine. So we're going to do y equals y shifted by 16 and then divided by 128. What does this mean, all this stuff that we're doing? And why is it written this way? I have no idea. Wish I could tell you. We need a y. That gets rid of our var a3. It's like I have too many parentheses. All right, so this is getting closer. It's still not quite right. So we have some registers that are incorrect. And we need to figure out what those are. This could be a couple things. It could be the order that they're declared. I'm going to move X and Y up. Oops. Let's see if there's any instructions that are wrong. The other thing that could be happening here is that maybe I have this part wrong. Let's check registers. Here's something. 31. I have this doing a plus equals, and that is not what's happening. There we go. That's all it was. Instead of doing a plus equals, we're doing it equals with the full expression in there. Why not a plus equals? Yeah, I don't know. I didn't write it. Looks like these two are out of order. 28. Again, out of order. Interesting. So GCC doesn't care about most of these things. It will replace these constants, put them in the appropriate place. Wow. This is going to be a perfect match, I think, at the end. And then we just have to go back and replace the correct variables in the PlayStation version. There we go. Perfect match. Let's go back to the PlayStation version. So we had something that originally looked pretty terse. If you moved all these temporary variables in locally, it would be even more terse. You could even make this even tighter by putting the increments in line down here. I would like that. I mean, I don't know if it's that great. GCC coalesces the shift by 16 and then divide by 128 into... But that's not the way that it's written. It's written like this. Is it? Is it? Let's replace some of our vars. So it's possible. So we're looking at the US PlayStation version here versus the EU PSP version. Something's happened between those two versions. The PSP version is derived from JP 1.0, which means that some of the bug fixes that existed in the US PlayStation release didn't make it in there. Some of the bug fixes and code changes. But this is not right. These are implemented very differently. Same logic. But why would they do this? So we have a perfect match on the PSP, but this is not the same. So then we have to figure out what part isn't the same. So I'm going to do this. I'm going to reintroduce var A3. We'll add a pause pointer var A3. I don't know if that's going to get us closer or not, but getting further away. It's possible that this is not a shift, but a multiply. Originally, this was a shift by 9. Let's put that back in. Let's see if that's close. It's getting a little closer. Oh, that's very close now. So it looks like I may be able to put this back. Is that a match? It looks like it. It looks like it's not. Am I not? Where's my line 21? Oh, this should be 4 and not... Yeah, that's what it is. There we go. This should be 4. Clever Heron. Chat must be broken. Is Clever Heron really an Anon, or is that me? Who knows? Good job, Clever Heron. So we have a match here now as well. And it's odd. So I'm going to take this back over to the PSP version. I don't think that this will... I don't think that this will work on the PSP version. Let's get rid of these. We're not going to get a perfect match here because of the symbols. If that's okay. Let's try it on the PSP version just to see. Yeah, it does not match over there. So I'm not sure why it's written so differently, but we should be able to take this back. We probably will need to add a symbol for 64. We'll see if that's the case or not. Oh, that's an interesting one. I frequently say not... short doesn't make it easy. Long doesn't make it hard. Really depends on the logic that is being used. So before I do this, I am going to see if we already have a 64 symbol, otherwise we'll need to add it. And there is one. So that's fine. And that did work. And so let's go over to the PSP version. Probably should update the symbol there. I'm not going to do it right now. Wrong folder. And we'll take that. Well. A very different location in this file, which means there's probably additional splits here that I'll need to work through as well. I'm going to make a comment here about this one. This one worked fine as well. Because these implementations are so different, they may be hard to find later. And let's look where after image is in the PSP, if I've marked that already. It's way down here. So we definitely have, yeah, some reordering that will need to be done because these are not in the same location at all. So from this, though, we know that there is going to be a split probably here. And possibly around the Aurochs after image as well. All right. I think that's it for today. Quick stream. We'll be back tomorrow. Go to soten.z.dev to learn more. And maybe chat will be working tomorrow. I don't know what happened. I don't why chat didn't load. I don't have any errors, just it's not there. So, we'll be back. This is Made Up of Wires. I appreciate everybody who has supported the channel over the 2 years we've been going. Decomping, we've been working on Aurochs. It's a little further than this. I just haven't submitted the code yet. And look at the reverse castle picking up. I'll see you tomorrow. Adios.